Just want to try and show you today the differences between sensible heat and latent heat. We've all boiled water many times over the years, and we probably never really paid a whole lot of attention to what was actually happening while this water was heating up and reaching its boiling point. So that's what I want to try and show you today. So we're starting out with some water. We're at roughly about 30 degrees Celsius right now, and we're going to just monitor the temperature of this water up until such time as it reaches its saturation point at atmospheric pressure, its boiling point at atmospheric pressure, which we know is 100 degrees Celsius. And as it is heating up, it is gathering sensible heat. Sensible heat is heat that can actually be measured with a thermometer. And we're just going to see what happens up until it does reach its boiling point. Alright, so the march up the temperature scale continues. We're at about 61 degrees Celsius, and what I'd like to do for you, just to point out something kind of interesting, is move this out of the way. And you'll see that there's little tiny bubbles being formed all over the sides of that beaker of water. And what this is dissolved gases that are actually coming out of solution. As the temperature increases in water, it becomes less able to dissolve gases like oxygen and carbon dioxide. So this is likely what you're seeing on the sides of the flask. Okay, so we're at 99 degrees Celsius right now, and we can see just right on the very bottom of the beaker where it's actually making contact with the hot plate. It's actually starting to boil a little bit, but the bulk of the water is still just a shade under 100 degrees Celsius. And as soon as it gets there, you'll notice that it'll start to boil very rapidly. But something else kind of peculiar is going to happen. We started out way down in the 20 degrees Celsius or the 30 degrees Celsius range, and it's continually increased in temperature up until such point as it gets to 100 degrees Celsius. And hopefully if we can get it the rest of the way to 100 degrees Celsius and get a really good rapid boil going, we'll see exactly what's going to happen here. And you can see it's getting closer and closer, starting to boil a little bit more sort of by the second, and maybe I'll just give it a little bit of extra heat here just to get it going. And what I'm expecting to happen now is as it reaches 100 degrees Celsius, it's going to start to boil. And even though I've still got the hot plate on and I've actually turned the temperature up a little bit, it's not going to increase in temperature anymore. And the reason for that is the water now has become saturated with sensible heat. Its saturation temperature at atmospheric pressure is 100 degrees Celsius, and it's reached that point, so it can't hold any more sensible heat. And you can see right now it's starting to boil more and more rapidly all the time. And there it's into a full boil. So interestingly enough, I've just turned this side up to keep the alarm off. And we'll just show you that it's actually just bouncing between 99 and 100 degrees Celsius, which probably speaks to the accuracy of my thermometer. And there it's flipped back to 100 again. So I could stand here all day like this and make a really long video for you, but one of the things you're going to notice that as long as this beaker is actually vented to atmosphere, that temperature is not going to go anywhere. It doesn't matter how much heat I put to it. In fact, what I'll try and show you is I'll put a whole lot more heat to it and try and get it boiling really rapidly. So I've got a really aggressive boil going there, and I'm adding a lot more heat to it with this propane torch. And I could put as many torches as I want on that, and that water will not go past 100 degrees Celsius. What's happening now is all the heat that I'm pouring into it is being absorbed as latent heat, and that heat's actually being used to make the phase conversion from liquid to a gas, from water to steam. And all the heat that's being absorbed and turning this water into steam bubbles is actually being lost up the top of the flask now. So the only way I'm going to be able to actually increase the temperature of this water is to actually change the pressure around it. So if I put a stopper in it and I allowed the pressure to build up in the flask, we'd actually start to see the temperature rise a little bit. And you can see that that temperature, in spite of what I'm doing here, is still at 100 degrees Celsius and is not going to go anywhere. Like I said, we could stand here all day and make a really, really long video, and that water will not go anywhere in terms of temperature. So that's the difference between sensible heat and latent heat.